Okay, so now we'll discuss the work done by a variable force. And in this case, we want to point out the fact that in this case, the force is varying. The force is varying in this case. All right, and we're still defining work, but this is work done when the force is varying. So, if an object is moved along a straight line by a continuously varying force f of x, notice we're not just using f. F here is a function of x, so the value of the force, or the amount of the force, depends on the x value, how far you are along the x-axis horizontally. Then the work, W, done by the force as the object is moved from x equals a to x equals b, so that's along the x-axis from x equals a to x equals b. So from x equals a to x equals b. All right, so, and this is given by, this work is going to be given by, well, W is equal to the limit as n approaches infinity of the sum of I from 1 to n of the f of ci delta xi, and that's actually equal to this integral. Let's take a look at this limit definition over here. What we have is we have this distance, or this interval from a to b, and what we want to do is we want to separate it into a partition. So this would be like my x0 for my partition. This would be my xn. So this would be the smallest separator from my partition. This would be the largest. And then I'm going to just partition the space from A to B into n intervals. So from x0 I'd have x1 would be the endpoint, the upper endpoint for my first interval. So I have a lower limit and an upper limit for my first interval. And then my second interval, they don't have to be equal. The intervals don't have to necessarily be equal. I'd have x2, and then I'd continue in this fraction all the way up to xn minus 1, and then that would be the last partition. So what I have here is I've divided this interval from A to B into n subintervals. And each one of these subintervals, I'm going to calculate the work on that particular subinterval. I'm going to calculate the work done on that particular subinterval by assuming that the work on that subinterval is constant. All right? So, for instance, what I'm going to first do is I'm going to choose a subinterval. If I is equal to 1, that would be the first subinterval from x0 to x1. If I is equal to 2, that would be the second subinterval from x1 to x2. If I were equal to 3, that would be the third subinterval from x2 to x3, and so forth. When I is equal to n, that's the nth subinterval from xn minus 1 to xn. So you just choose a value on one of these subintervals, on the ith subinterval, for instance. And for instance, if I was looking at this interval right here from x1 to x2, I could choose the value and call it c2, and then I'd calculate the force on that subinterval by plugging in c2, because if it's a constant force on this subinterval, then regardless of which point I take from the subinterval, I'll get the same value for the force. And I'll multiply it by the length of that subinterval, the distance that the force is going to carry that object through this subinterval. All right? So I'm just going to choose a particular value for Ci on the ith subinterval, calculate the force, and then I'm going to multiply it by the distance, or the length of that subinterval. That's going to give me the work done on that subinterval. Then I'm going to add up all those little intervals of work to get the total work. And I want to take the limit of this as n goes to infinity, so that I can have an infinite number of subintervals. That way, my approximation will be a lot better. Because this is really an approximation until we add the limit, because we can't really assume that each subinterval, the force is constant on that subinterval. So we make the subintervals as small as possible by making as many subintervals as possible. So we want n to approach infinity, and this is actually the definition of this integral. This is the definition of this integral. So in order to find the force done by, or sorry, the work done by a varying force over a distance from A to B, what we have to do is we have to integrate from A to B the force with respect to the distance. So this is the definition of the work done by a variable force.